Linear functions and slope. Slope measures how steep a line is. It's the ratio of the vertical change to the horizontal change, and you might remember that it is the rise over the run. This is the equation that we use to find the slope of a line if we have any 2 points on that line. M is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So we're going to use that formula to find the slope of the line passing through each pair of points. Now the best thing to do whenever we have a set of points is to label our points. We know that every time we have an ordered pair, the first number is our x and the second number is our y. But since we have 2 sets of points, we're going to let one of those sets be our x and y 1s and the other set to be our x and our y 2s. Then we just take them and plug them into our equation, the slope formula. Okay, so my slope is going to equal the 2 y's, so that would be y2, which is negative 2, minus y1, y sub 1, which is 4, over x sub 2, which is negative 4, minus x sub 1, which is negative 3. Okay, so negative 2 minus 4 would be negative 6, and then negative 4 minus a negative 3, that would be like plus 3, would be negative 1, and that would simplify to just be a positive 6. Alright, let's do the same thing in the second set of points that we have. I'll say this is x sub 1 and y sub 1. Don't do that. Don't make one of them a 1 and the other one a 2. And x sub 2 and y sub 2. So again, the y's go on top. 5 minus negative 2 over my x's, and the same x, the x that was with the y, the first y on top, the x that's the ordered pair with the first y that's on top needs to go first on the bottom. That's why we label them. So negative 1 minus 4. Alright, so 5 minus a negative 2, that's the same as 5 plus 2, which would be 7. And negative 1 minus 4, that would be negative 5. And you can bring that negative sign out in front. And we have a negative 7/5 for our slope. Now, there are 4 possibilities for the slope of a line. A positive slope rises from left to right. A negative slope is a line that falls from left to right. A 0 slope would be a horizontal line, and an undefined slope would be a vertical line. So if we look back at the 2 slopes that we just found, the first slope was 6. So that means it's a positive 6. So that tells us that it would be a line that rises from left to right. Our negative 7 over 5, since it's negative, then we know that our line would be, the slope of our line would be falling from left to right. And then if we had a slope that was 0, then it would be a horizontal line. And if we had a slope that was undefined, meaning we have a 0 on the bottom of our slope, like 5 over 0 or 2 over 0, then it would be a vertical line. Point slope form of an equation of a line is y minus y sub 1 equals m times x minus x sub 1. And in this formula, m is the slope, just like it was in the slope formula. And then the x and the y that have the 1's beside it, that's going to be our point. The other x and the y just stay in x and a y. But those ones that I've marked, those are places that we plug numbers into. All right, write the point-slope form of the equation of a line with a slope of 6 that passes through the point 2, -5. Then solve for y. Okay, so I'm going to copy down the point-slope form. Okay, so the information that they gave us was the slope and the point. And like I said, the point, that's going to be my x sub 1 and my y sub 1. And the other x and y stay x and y. So this first y just stays a y minus my y sub 1. Well, my y sub 1 would be this right here. So minus -5 equals m, which is my slope, times x minus x sub 1, which is 2. Okay, so that is the equation written in point-slope form. But then they want us to solve for y. Okay, so to solve for y, first of all, y minus the -5, that would be y plus 5. And then I want to distribute the 6 to get rid of the parentheses. So that's 6x minus 12. Okay, so to solve for y, all I need to do is subtract 5. And I have y is equal to 6x minus 17. Okay, this example says write the point-slope form of the equation of a line passing through the points -2, -1, and -1, -6, and then solve for y. Well, in that point-slope form, the equation has us plug in a point and a slope, but we're not given the slope. We're given 2 points. So how do you think we could find the slope of the line given 2 points? We use the slope formula, which is the m is equal to y2 minus y1 over x2 minus x1. Okay, so let me plug the points into that. So if I do like I did in the past, and I'll let the second set be my y2s, my x2 and my y2, and this is my x1 and my y1. If I plug those into the equation or the formula, y2 minus y1 would be -6 minus -1 over x2 minus x1. That would be -1 minus -2. All right, so that would be 6 plus 1, because minus and -1 would be like plus. So that would be -5 or -5 over -1 plus 2 would be 1. So my slope is just -5. Okay, so now that I have the slope of the line, I can plug it into point-slope form. I have 2 points, but I only need 1 point for the point-slope form. It does not matter which ordered pair you use. I'm going to choose this one, so let's just use that. And it doesn't matter to plug into the point-slope form. So the point-slope form, remember, is y minus y sub 1. So y minus my y sub 1 would be -1 equals m. What is my m? It's -5. That's my slope. Times x minus x sub 1, which is -2. Okay, so that's point-slope form. You could go ahead and clean that up and make that y plus 1, and that would be considered point-slope form. Clean up your, don't have double symbols, double minus signs or plus signs. Okay, so that would also be considered to be point-slope form. But then they want us again to solve for y. So to solve for y, I'm going to distribute, and I have -5x minus 10, and then subtract 1 from both sides. And that is my equation solved for y. Slope-intercept form is y equals mx plus b, where, again, m represents the slope, and b is the y-intercept. Well, remember, the intercept is where it crosses that axis. So the y-intercept would be where it crosses the y-axis. Now, if you'll notice, when they kept having us solve for y, that was actually getting our equations in slope-intercept form. See, this would be y equals mx plus b. Graphing an equation that's in slope-intercept form, all we have to do is pull out those two pieces of information, the slope and the y-intercept. Then the first thing that we do is plot the y-intercept, because our slope tells us the slant of the line, but it doesn't tell us where our line needs to go on the graph. So that's the first thing we need to know. We need to know where to put it, and our y-intercept tells us that. Then we use the slope from that point, from our y-intercept, we're going to do rise over run to get another point on the line. And then when we connect our points, we have a line. So we're going to graph this function. It's in slope-intercept form. And we're going to pull out the slope. So m is whatever is in front of x, and that would be 3/5. And our y-intercept, in this case, would be 1. So like I said, we plot the y-intercept first. My y-intercept is 1, so on my y-axis, I'm going to go up 1 and put a dot. And then my slope is 3/5. So from that dot, I'm going to rise 3 and run 5. Okay, and then I would put another dot. And you can do that as many times as you want to. You could rise 3 and run 5 again. That kind of runs off of my graph. But if you wanted to do that, it'd be about right there. And then we just connect our dots. And always make sure that you put arrows on the end, because this is a line and a line keeps going. It doesn't stop. And that's how we draw a line using slope-intercept form. Now, remember we said that a positive slope told us that our line would rise from left to right. So our slope was positive and our line is rising from left to right. If we had a negative slope, then our line should be falling from left to right. If it's not, then you didn't graph it correctly. The equation of a horizontal line is y equals some number, and horizontal lines have a slope of 0. The equation of a vertical line is x equals some number, and vertical lines have a slope that's undefined. No vertical line is a function. Do you know why that is? Because a function has to pass the vertical line test. And remember, for a vertical line test, if you have a vertical line, say if this was our graph, if we tried to pass a vertical line on top of it, it would touch the graph in more than one spot at a time. So it would not pass the vertical line test. But any other line, a diagonal line, or a horizontal line, would pass the vertical line test. So every other type of line besides a vertical line is a function. Now, I have a way to help you remember all of this stuff about horizontal and vertical lines, and it's using this little acronym, HOI, VUX. And let me tell you what that stands for. So in HOI stands for horizontal lines have a slope of 0, and all horizontal lines, the equation is y equals some number. VUX helps us to remember that vertical lines have a slope that is undefined, and all vertical lines have an equation of x equals some number. So if you can remember that acronym, that helps you to remember what types of lines have what types of slopes and what their equations look like. Now, to graph one of those types of equations is very simple. If we're going to graph the equation, the first equation of y equals -3, we're going to go on our y-axis, just like it says, y equals -3. So on our y-axis, we're going to go to -3 and put a dot. Now, Hoy tells us that if it's y, it's going to be a horizontal line. So I put my dot on -3 on y, and then I draw a horizontal line through it. And that's it. Again, make sure that you put arrows on the ends of your line. Okay, so then for B, we have x equals -3. So since it's x equals -3, on my x-axis, I'm going to go to -3 and put a dot. And then Vux tells us that if our equation is x equals something, then it's a vertical line. So I'm going to draw a vertical line through that point. And that's all it takes to graph horizontal and vertical lines. Okay, the last form of an equation is the general form of an equation. Sometimes this is called standard form. Ax plus by plus c equals 0. And in this form, a and b cannot be 0. This is also, I just said this is also called standard form. And we can't plug things directly into this equation. For our point-slope form and for our slope-intercept form, we can plug things into that equation or pull things out of those equations. But general form is just a way to write an equation, so we can rearrange an equation and get it in general form. Another thing that you need to be aware of, if you're told to put an equation in general form or standard form, it cannot contain fractions. So if it has a fraction in the equation, then you need to multiply everything by the least common denominator to get rid of the fractions in the equation. All right, find the slope and the y-intercept of the line whose equation is 3x plus 6y minus 12 equals 0, and then use those to graph the line. So this is in general form, and like I said, we can't pull the stuff directly out of general form. So we're going to have to rearrange it and get it in slope-intercept form to find the slope and the y-intercept. So do you remember what slope-intercept is? Y equals mx plus b. So that means we need to get y by itself in the equation. All right, so if I want to get y by itself, I'm going to subtract 3x from both sides and add 12 to both sides. So I have 6y equals -3x plus 12. And then I need to divide everything by 6. And I get y equals, that would reduce to a -1/2 x plus 2. Now that I have it in slope-intercept form, I can pull out those pieces of information. My slope is a -1/2, and my y-intercept is 2. Okay, which piece of information do I use first? I use the y-intercept. So on my y-axis, I'm going to go up to 2 and put a dot. Now, this time my slope is negative. So I know that my line should be falling from left to right. Also, when I have a slope that's negative, I need to choose to put my negative sign with either my numerator or my denominator, but not both. So this would either be -1 over +2 or +1 over -2. Why would I not do -1 over -2? Because that would make it positive, and it's not positive, it's negative. So I either do -1 over +2 or +1 over -2. So if I go to my y-intercept, if I do -1 +2, that means I would go down 1 and to the right 2. And put a dot. Or, like I said, I could go positive 1, negative 2. If I did that, I would go up 1 and to the left 2. And put a dot. And you see how either way that's still part of the same line? So let me connect my dots. And like I said, since my slope was negative, my line should be falling from left to right, which it is. So I know that I graphed it correctly. You can also use the intercepts to graph an equation that's in standard form. And the way that we find the intercepts are we plug in 0 for the opposite of what we're looking for. So if we're looking for the x-intercept, we're going to plug in 0 for y and solve for x. If we're looking for the y-intercept, we're going to plug in 0 for x and solve for y. And when we find those 2 points, those 2 intercepts, we can plot those 2 points, connect them, and we have our line. So let's graph this equation using the intercepts. So like I said, for whichever one we're looking for, we're going to plug in 0 for the opposite. So for our x-intercept, I'm going to plug in 0 for y. So let me do that. I have 3x minus 2 times 0 minus 6 equals 0. Okay, so negative 2 times 0 is just 0, so that just kind of goes away. And then I'm left with 3x minus 6 equals 0. So let me solve this for x. I have 3x equals 6. Divide by 3. And x equals 2. So my x-intercept is 2. So on my x-axis, I'm going to go to 2 and put a dot. Okay, so then to find my y-intercept, I'm going to plug in 0 for x. All right, so it's 3 times 0 minus 2y minus 6 equals 0. Okay, so 3 times 0 is 0, so that just kind of goes away, and I have negative 2y minus 6 equals 0. I'm going to add 6 and divide by negative 2, and I get y equals negative 3. So on my y-axis, I'm going to go down to negative 3 and put a dot. And I connect my dots, and there I have my line.